Hello friends, today I will discuss about impact of KZ factor. KZ is also called residual compensation factor or zero sequence compensation factor on distance relay reach on earth fault. So here a figure has been shown where a earth fault occur after a certain distance. So what actually distance relay measure the distance in terms of positive sequence impedance only. So here the positive sequence impedance at the point of earth fault is Z1 and the ground return path impedance is Zn. So fault occur at rate phase. Due to this, at rate phase Ia current flows and the return current, ground return current is In, and distance relay what actually measure the impedance in terms of positive sequence impedance only. So here the value of the Zn is unknown. So our motive is to calculate the Zn value in terms of Z1 only. So in this video I will discuss about what the KZ factor impact on distance relay reach on earth fault. So due to flow of the earth fault, zero sequence current will flow in the neutral path, that is through the impedance which is called Zn, and it will equally distribute to each phase, that is red, yellow and blue phase, and at the point of fault point. So I0 is the zero sequence current and it will distribute each phase and come back to the source. So 3I0 current flows in the neutral path. So V0 is the zero sequence voltage and it will calculated V0 is equal to Z1 into I0 plus Zn into 3I0, or we can write that V0 by 3I0 is equal to Z1 by 3 plus Zn. As Zn is the unknown quantity, our motive is to calculate the Z1 in terms of Zn in terms of Z1 only. So we can write V0 by 3I0 is equal to Z1 plus 3Zn divided by 3. Now V0 by I0 is equal to Z0, which is zero sequence impedance of the transmission line. So here we can write that Z1 plus 3Zn is equal to Z0. Therefore we can write Zn is equal to Z0 minus Z1 divided by 3. So during earth fault, what actually distance relay measure the loop impedance? Here loop impedance is Z1 plus Zn. Here Zn is equal to Kn into Z1. So here the loop impedance which is measured by the distance relay is Z1 into 1 plus Kn. Here Kn is equal to Z0 minus Z1 divided by 3 Z1. Kn is called zero sequence compensation factor or residual compensation factor. So without the value of the Kn, distance relay may underreach due to earth fault, and it will not sense the fault actually which is happened in the distance relay zone. So in this video I'll discuss with an example how the distance relay will underreach due to earth fault if zero sequence compensation factor value is not given in the distance relay. In this figure, a single line diagram has been shown where a substation A is connected with a source voltage is 132 kV, that is the phase to phase voltage, or we can write that is line to line voltage, and is the source impedance. So source impedance of the positive sequence impedance and negative sequence impedance is equal, that is 5 ohm, and zero sequence impedance is also equal, that is 5 ohm. And fault occur at point F in between substation A and substation B at a distance of 10 ohm. So we can consider that 10 ohm is equal to 10 km for simplicity, and the zero sequence impedance up to which the fault occur is 30 ohm. So in case of transmission line, positive and negative sequence impedance are equal, that is 10 ohm, and zero sequence impedance is much higher than that of the positive and negative sequence impedance. So first I will calculate the error without the kz factor. So in this figure, at point F, fault occur due to earth fault occur at point F. From substation A end, the distance relay will sense this fault and it will measure the fault in terms of distance, in terms of ohm. So the value which distance relay measure the fault in terms of distance should be 10 ohm. So for simplicity we can say that 10 ohms is equal to 10 kilometer and the fault occur at point F is equal to 10 kilometer from substation A end. So it should be noted that from substation A end the distance relay measure the distance at 10 kilometer from substation A end. So let us see what actually distance relay will see this fault without the factor kz factor. So due to earth fault, there will be three sequence component current, that is positive sequence component current, negative sequence current and zero sequence component of current, and this three component of current will be in series and will be equal. That is I1 is equal to I2 is equal to I0, and fault current will be IR, that is fault occur at red phase, and IR is equal to 3 into I0. So the sequence component of the current has been shown in this figure. So here for positive sequence component diagram, we have some of the positive sequence component of source and positive sequence component of the line up to fault point, which is equal to 5 and 10 ohm respectively. And here source voltage is 132 by root 3, that is the phase to earth voltage. And for negative sequence component diagram, we have negative sequence component of impedance of source and negative sequence component of impedance of line up to fault point, that is 5 and 10 ohm respectively. And for zero sequence impedance diagram, we have zero sequence impedance of source and zero sequence impedance of line up to fault point, that is 5 ohm and 10 ohm 30 ohm respectively. So total impedance comes as 65 ohm. So value of I1 is equal to I2 is equal to I0, since these three components are in series, equal to 132 divided by root 3 into 65, which comes as 1172 ampere or 1.172 kiloampere. So positive sequence impedance of red phase comes as red phase voltage minus I1 into Z1, which is 132 by 1.732 minus 1.172 into 5, which comes as 70.35 kV. Negative sequence impedance, negative sequence voltage, that is V2R is equal to minus I2 into ZS2. So it comes as minus 1.172 into 5, which is equal to minus 5.86 kV, and zero sequence voltage, which is V0R is equal to minus I0 into ZS0, which is equal to minus 1.172 into 5, which is equal to minus 5.86 kV. So since at is relay point is point A, that is why uh, the V2R is equal to minus I2 into ZS2 and V0R is equal to minus I0 into ZS0. So at relay point we'll calculate the VR, that is the voltage, in terms of sum of the three sequence voltage, that is VR is equal to sum of positive sequence voltage, negative sequence voltage and zero sequence voltage. So now we can calculate the ZR, that is the impedance in terms of distance without the value kz. So it comes as, that is the red phase voltage at relay point divided by red phase current at relay point, which is equal to 58.63, since VR is equal to V1R plus V2R plus V0R, which is equal to 70.35 minus 5.86 minus 5.86 is equal to 58.63 kV. So VR is equal to 58.63 divided by IR, which is 3 into 1.172 kiloampere. So ZR comes as 16.7 ohm. So fault occur at a point distance in terms of impedance is equal to 10 ohm from substation A end, but distance relay will see the fault at a distance in terms of impedance is 16.7 ohm. So if for simplicity we can consider that 10 ohm is equal to 10 kilometer, then it should be 10 kilometer from substation A end, but distance relay will see the fault point at a distance of 16.7 kilometer from substation A end. So without the value of kz, distance will underreach, and it may that fault occur at zone 1, but distance relay will see that this fault at zone 2. So the zone location may be changed due to error due to without considering the kz or zero sequence compensation factor. Now we will calculate the distance with the value of the kz factor. Now kz factor is considered, and for the same fault location at point F, we will calculate the value of the distance in terms of ohm at point F. And now we will calculate the distance in terms of impedance with the value of kz factor. So kz factor is equal to z0 minus z1 divided by 3z1. Let Z0 and Z1 as the zero sequence impedance of the transmission line and a positive sequence impedance of the transmission line up to fault point, which is equal to 30 and 10 ohm respectively. So Kz comes as 30 minus 10 divided by 3 into 10, which is equal to 0.67. So distance relay which measure the distance in terms of impedance Z is equal to with Kz is equal to VR divided by IR into 1 plus Kz. So VR by IR is equal to 16.67 divided by 1 plus 0.67, which comes as 10 ohm. So with properly included the Kz factor, that is the zero sequence compensation factor, we can conclude that distance relay will calculate the distance accurately up to fault point. So now the distance which is calculated by the distance relay at substation A end is 10 kilometer, or we can say impedance in terms of ohm is 10 ohm. So distance relay can accurately calculate the distance with the value kz factor. So friends, if you like my video, then you can go through my channel and do subscribe my channel, and also press bell button for notification of videos to be uploaded in future. Thank you for watching this video. Thank you.